A gas sample containing 0.3250 moles of a compound is trapped in a chamber with a volume of 2.460 liters. If the temperature of the gas is 26.8 degrees Celsius, what is its pressure in torr? Assume an ideal gas law behavior. This is going to use the ideal gas law equation to solve this problem. How do we know to use that? The combined gas law equation only is used when we have two different states of gases. And here we have this gas is only at one state of conditions. We have given only one temperature. We're given one volume. We're asked to calculate only one pressure. There's no other pressure given. So our equation, of course, is going to be PV equals nRT. Our gas constant R would be given 0.0821 liter atmospheres per Kelvin mole. That would be given to you. You don't have to memorize that. In this problem, they are asking us to calculate what is the pressure in torr. So P is going to be our unknown here. So we got to do a little bit of algebra, which is no big deal. We're just going to divide both sides of the equation by volume. So we get P is equal to nRT over V. Now we got to make sure that we have our variables in the proper units. N, number of moles, that's given. Let's highlight it here. Here's our number of moles. R is already given. Temperature problem. We're given degrees Celsius. We need Kelvin, so let's calculate our temperature here. T is going to be 26.8 degrees Celsius plus 273.15. Rounding to the correct number of decimal places, we get exactly 300.0 kelvins. So this is the temperature we're going to use. Let's highlight that. This is the number. And then our downstairs variable volume, we do have the correct units here for liters. So now we can just substitute in. So let's scroll down a little bit. Our pressure then is going to be equal to number of moles, 325, 0.3250 moles. Let's keep track of our units. Our gas constant, 0.0821 liter atmospheres per Kelvin mole. And our temperature, 300.0 kelvins. And then downstairs we have the volume. The volume is given as 2.460 liters. So we've got 2.460 liters. Now let's make sure our units cancel. Moles upstairs cancels moles downstairs upstairs. Kelvins upstairs cancels kelvins downstairs upstairs. Liters upstairs cancels liters upstairs downstairs. And that takes care of everything except atmospheres, which is upstairs, which is good because we're solving for pressure. So P, now doing the math, gives us a value of 3.25 atmospheres. So the unit must be atmospheres using the ideal gas law equation with the value for R that we have. The problem asks us for the pressure in torr. So our conversion factor, 760 torr per 1 atmosphere. So torr goes upstairs, 1 atmosphere goes downstairs, so the unit of atmospheres cancels. And now we're going to multiply this through, and we're going to get 2471 torr as our final answer. We do have, well, that should be 3 significant figures the way I did the calculation, because I've only got 3 significant figures here with our gas constant, and I did correctly round our pressure in atmospheres to 3 significant figures. So our correct answer is going to be 2.47 times 10 to the 3rd torr.